Hello everyone, I will briefly introduce our paper, a structure-aware invariant learning framework for node-level graph OOD generalization. The node-level OOD issue denotes there are distribution shifts between the training and test nodes, which may originate from the node feature and graph structure shifts, as demonstrated in diagrams. Because node samples are interconnected and are not independent, it's harder to identify the specific environment. The node-level OOD generalization study is more challenging and less explored. To investigate this issue, invariant learning is adopted by most research, and due to the difficulties in obtaining environment labels, graph augmentation is widely exploited to construct diverse training environments for invariant learning. However, current methods still face the following challenges. First, current augmentations generally focus more on facilitating diversity while faltering in preserving invariant patterns. Second, they disregard the constraint on the graph-specific structure invariants, which may cause including spurious information in the GNN's aggregation patterns, thus making its parameter overfitting. To address the above issues, we first preserve the invariant patterns while boosting the diversity of the augmented environments. Additionally, we define the structure embedding and provide more fine-grained constraints on the invariant of aggregated features to prevent GNN's parameter overfitting. More specifically, first, besides promoting the diversity to preserve invariant patterns in augmentations, we enable representations from each augmentation to be predictive and invariant. Moreover, we define the structure embedding and develop structural invariance laws to further impose invariant constraints on the neighborhood aggregation patterns. With the augmented environments, we conduct structure-aware invariant learning to train invariant GNNs. First, we develop invariant laws with variance regularization. Then, we propose a class-level structure embedding alignment loss to minimize the disparity between the structure embedding and anchor to constrain the aggregated feature invariance within the same class. We conduct extensive experiments on 4 transductive datasets with concept or covariate shifts and other 3 inductive datasets. The classification results on all datasets demonstrate the effectiveness and the superior OOD generalization ability of our model. Thank you.